Hello guys. So let's move to the next question on projectile motions. So this time a ball is thrown at an angle of 20 degree. So a ball is thrown at an angle of 20 degree with 11 meter per second. Okay, with respect to the horizontal axis. So the question is, how far does it travel in the horizontal direction? So meaning you need to find the range of this projectile. And the second is the total time taken for the ball to reach the ground, the time of flight, and the third part is what is the maximum height reached by this ball. So how do you find this? So this time the information is the ball is actually thrown 11 meter per second at 20 degree. Okay, so what I'm going to do is I'm going to divide now this velocity vector into two perpendicular components. One is in the horizontal direction, other one is in the vertical direction. So in the horizontal direction, I'll call this as my Vx component. So the Vx component would be 11 cos 20 degree. So I explained this. Remember, when you divide a vector towards the given angle, we call cos. So 11 cos 20 degree. And if you divide away from the angle, so this is our away from the angle, this way we will get sine component. So this is V cos 20 degree and this is V velocity V sine 20 degree. So if I simplify this, 11 into cos 20, you will get in the horizontal direction 10.34 meter per second. In the vertical direction, velocity component is 3.76 meter per second. So this is our initial speed in the horizontal and the vertical direction. Sorry. So the first part is how far does it travel in the horizontal direction. So before I do the first part, I'll do the second part of the problem, because to solve the first part you need to have the total time of flight. So first I'll solve the second part of the problem. I need to find the total time of flight. So I'll use this s equal to ut plus half gt squared in the horizontal direction. Sorry, in the vertical direction. So as I explained in the earlier video, if I use this s equal to ut plus half at squared for the total journey, goes up and come back to the same point, I can say that total displacement is 0. Okay, so the total displacement becomes 0 because it goes up and come back to the same point. And the upward velocity component is, we found here 3.76. So 3.76 time our total time of flight, our t. Minus, why here minus sign? Because I told you these equations are actually our vector equations. So you need to specify the direction. So here the direction is upward. Actually we are applying the equation upward, but the gravity is actually downward. So I put a minus sign here. Half 10 into t squared. So if you simplify this, you will find two answers for t. One is t equal to 0, other one is t equal to 0.75. So how do you explain these two answers? The first answer, t equal to 0, when you actually about to throw the ball. Okay, so when you about to throw the ball, you start your stopwatch. So that is, so in this position time is equal to 0, okay, and again it goes upward and come back to the same point. Time taken is for that journey 0.75 seconds. So t equal to 0, you are ready to throw the ball, and 0.75 seconds the ball goes up and come back to the same point. So I mean, here I'm explaining actually go back and come back to the same point mean to become the displacement becomes 0, okay. So how do you do the second part of the problem? Yeah, sorry, not the second part, the first part, because we did this one first, the total time taken. After that, how far does it travel in the horizontal direction? So how do you do this? I'm going to use now s equal to ut plus half at squared in the horizontal direction. Remember, we agreed, so this part should be 0 if we apply the equation, because there is no horizontal acceleration. So this will be 0. So I will say the total range is r is equal to the speed in the horizontal direction is 10.34 into the total time of flight. Here we calculated 0.75. So if you multiply these two values, you will get 7.76 meters. So 7.76 meter is the total range, okay. If you throw a ball at 20 degree with 11 meter per second, the total range would be close to 7.76 meters. And the third part of the problem is you need to find the height, the maximum height. You need to find this height reached by this object. So how do you find this? I can find this in several ways, okay. So even sometime you can use the conservation of energy to find the height, but here I will use simply our equation v squared is equal to u squared plus 2gs, and here we said this region the velocity in the vertical direction is 0. We will be having only the horizontal component. This doesn't change. We said this Vx would be 10.34, okay. So this doesn't change, right? If you pick any point, this velocity vector doesn't change. So I'll use this v squared is equal to u squared plus 2gs. So the velocity on the top would be 0. U squared is 3.76 squared minus, I'll put a minus sign because the gravity is downward, 2 into 10 into h, the height. So if you simplify this, you will get the total distance, sorry, the height, the maximum height reached by the object is 0.71 meters. I hope you got the idea. Thank you for watching.